if you want, I can go into gyroscopes.
Oh, sorry, I'm getting some background. Yeah, if you'd like to, yeah.
Okay. Well, in terms of when I started out, uh, uh, yeah, my brother-in-law, he was a professor of astronomy at Lehigh University, Dr. George McCluskey, and he read Analog Magazine. I'm not sure. Analog Magazine has a section on fact, and it has science fiction, and one section it had on there was the Dean drive, and the Dean drive. I'm not really fond of the Dean drive, but in terms of just getting me into seeing centrifugal force being used to propel something, Jim Cox was into the Dean drive, which is basically an oscillator. And to me, the timing and the complexity. One thing I did get involved with there. I'll get the gyroscopes later. I'll just this is quite real. There's a patent. The patent number is US 3404854. It's DeBella, and it's device for imparting motion to a body. DeBella was a professor of naval engineering at the University of Genoa. Few knew that. He spoke Italian and no English, and I tried communicating with him. And what happens is the DeBella device, when everybody looks at it, they think it runs or it propels on centrifugal force. What it is, it's a Mobius loop. Everyone's familiar with a Mobius loop. When you take a miter gear and put an eccentric on it and lock one, you'll generate this nice wave. And I had a friend of mine who made one. He was Bob Jones. He went to University of Kansas, Emporia. And he says, Ron, I can't get it to work. And the thing is, what it is, it works one moment. It has a variable moment of inertia. Centrifugal force does not play a role in any part of it. And when DeBella filed for the patent, the examiner, whenever you file for one of these patents, you usually get a US 35-101 rejection. And the device works because the device lacks utility because it's inoperable. It violates Newton's third law. And but there's a catch to it. You can overcome that objection, the US 35-101, by presenting a working model or having documentation at a university. So DeBella has about maybe 20 pages of this device, and he built canoes. He was interested, oddly enough, in ship propulsion. He was not concerned about going. He wanted something more efficient than a propeller, and he thought this eccentric might work better. There's a picture of him, and these pictures are poor. I ordered the patent examiner file. In the old days, you could Kanofsky and Associates. They have firms around the patent office that would go in and photocopy. Once a patent is issued, all the back data on that is public information. And when he was ordered to present documentation that his device worked, DeBella went in and he showed him all the devices he made. It passed the pendulum. He had a torsion pendulum. It would wind up against the torsion pendulum. He also did a balloon test, which was kind of intriguing. It would lift into the atmosphere. And so in terms of these mechanical devices, they do work. Newton's third law, they always cite it. And my comment on Newton's third law, Newton's third law holds for one plane. If you take the rotation out of a plane, you change a lot of things, like with Gamble and gyroscopes. My first introduction to gyroscopic propulsion was Hosford Dudley Kellogg. I went to Villanova, and he lived in Ardmore. And he has a patent. It's H.D. Kellogg. The patent is entitled Gyro Thrust. What makes it a bit odd is our patent system that's observable only goes back to 1976. This was before that. If you're researching gyroscopic propulsion, one of the big sources is it's gyroscope.org. There's I think Mark, when he bought the gyroscope, he bought it from that company. They have the list of all the gyroscopic patents there. I'd say maybe at least a dozen. And what Kellogg, he said basically that the traction on space, he says, is only a few degrees. He says once you get beyond maybe 5 degrees, he says you lost most of the effectiveness. And so what he did is he measured. He had a constant force spring, and he had weights on a turntable, and he'd measure how much he would get per pound of spring. And he says, no, he says the best bet when you're working with a gyroscopic propulsion, he says everybody thinks a flip is the best. And so, anyways, the other fellow is Richard E. Foster. Foster has a device, and the sad part about the Foster device is it's unidirectional device for the device for I'll give it to you, but it's the Foster gyroscope socket device that you can find by way of it's Richard E. Foster. And what he does with a gyroscope, you can, as we all know, you can move it. I'll say this is a gyroscope. You can move it like this, and you can move it like this without resistance. So what Foster does is he has basically a circle, and over the top of the circle, he brings the gyroscope from 9 o'clock position over to 3 o'clock position, and that basically does not require much effort. And then what he does, when he gets at the 3 o'clock position to the 9 o'clock return, he tumbles it. And when he tumbles it, that needs resistance on the arm. It's like rowing, like Kellogg said. He says you have to look at these gyroscopes as if you're rowing an oar through water. When you pull the oar back, you have traction, and then when you feather it, you can bring it back. So what Foster did, he basically feathered the gyroscope, tumbled it, gave resistance, and this would move across the floor. Only thing, it was rather complex. It didn't run very fast. And the tragic part about it is it's figure 4. Figure 4, the patent attorney who wrote it only gives the top of holding the gyroscope flat. You only realize that it's being tumbled in the 3 to 9 o'clock position when you read the specifications. If Foster would have had a good diagram, it's just it was such a waste because everybody, when they look at a patent, especially the mechanical patent, they look at the drawings, and the drawing was simply 1/2 of the cycle, and so I one time wrote an SBIR for him. I had university backing. I went through all of the bells and everything I needed to do for it, and it was an immense amount of work, immense amount of time. And the NASA SBR, they just rejected it, and so it's really a shame because the Air Force has something called afworks.com. It's similar. They're looking for innovative tools, and I'm not sure it's anyhow. But that's where I'm with the gyroscopes. I will add one thing. Another good way of making an inertial device is when you spin a liquid, everything will go to the outside. This is a relatively good example. If you spin this a container with water, the water will go out and it'll self-balance. If you now take an object, immerse it, as we know, the specific gravity of water is 1. If you take a piece of, I'll use the word plastic, specific gravity of one, and put it in there, what happens is all the water will come in and self-balance. So what you'll have is you have a way of taking this thing into balance and out of balance by using fluids. And yeah, I made one, and the patent office gave me such a hard time on it. It wasn't worth it. I go, just they're not going to issue it anyhow. But anyhow, fluids are a good way of making. They say use mercury, but you can use heavier fluids, but there are several of them that use fluids to self-balance, and some of these have results with them. And so whenever I look at a patent, I look, is the patent speculative, or they actually give some kind of indication that they made something and they're getting results out of it. And but in terms of space drives, at the Jim Cox, the website is for anti-gravity news, as I mentioned before, is Padrak, PADRAK.com/AGN, and in there are the numbers of the Foster device, the gyroscope device. I think the Kellogg device it's basically a summary of the periodicals he put out. A lot of it is space drives. He didn't have too much on Thomas Townsend Brown, and as I mentioned, one of the best sources for Thomas Townsend, not best, but I use Wikipedia as something quick and dirty. And there is the Byfield Brown effect on the Wikipedia, and also Rex Research. Rex Research has a lot of the dissident science, and also there's naturalphilosophy.org. There's a section of the website that is dedicated to dissident scientists. It's been around for a while. A lot of people are on that list, and it's just interesting because you'll get a lot of it is gravity related. And so in terms of sources, I will be sending you some of the Charles Yost Electric Spacecraft Journal. He covers Alzafon. Yost did Alzafon. It was it's off topic. It was I don't know if Charles told me but there are a lot of experiments and a lot of things that people do that aren't really known. So that's I'm up against what? I'm up against an hour 30. So anyhow, this is where I am, and so any thoughts or people want to make comments or